Okay, the first normal form. Okay, let's see the first normal form, the basic one. In the first normal form, this allows composite attribute. We not allow multi-value attributes. We also not allow nest relations attributes whose values for an individual tuples are non-atomic. Okay, considered to be a part of definitions of relation. Most relational database management systems allow only those relations to be defined that are the first normal form. Okay, so here is the example. Normalization into first normal form. The schema of the department, we have the number is the key, and now is primary key. Okay, so this one determine the name, the manager SSN, the location. Okay, so and B is the sample state of relation department. Sample state, as you can see at the location. This one store multi-value inside. If we have multi-value inside the tuples, this one not satisfy the first normal form. So, if not satisfy, what should we do? C is the first normal form version of the same relation with redundancy. Not a good one, but already satisfied the first normal form. So we changed the multi-value attributes here to separate into three rows from 3 values in the multi-value attribute array. We changed to 3 rows. But there are a lot of duplications information, but already past the first normal form. Okay, as you can see here, at first we have just the number is a key, primary key, but when you transform it, change it to separate the value, multi-value to each row, we have to add that one as the primary key. So we have to use both of them, the number and the location, together as a primary key. Okay. Now C is already the first normal form with redundancy. Okay. The other one here we have M project. The schema M project relation with a nest relation. The project here, the project, this is a nest relation. And B is the example state of the data in M project. So we can see that here is just one row, but for the nest we have cells like this one, 2 rows paired to just one. In Excel, it's like a merged cell, right? Like a merged cell here. You can see that this is like a merged cell. So this one is not satisfied the first normal form. How to change it is very simple. You just separate the nest. Separate the nest to be the new table, and also bring the key to the nest. So actually when we have the functional dependencies, we have to write down the functional dependency. Actually this table is the SSN and P name, right? And both of them determine hours, and SSN determine ename. So if you know the functional dependency, you just separate the functional dependency into the new one. Here is SSN and ename, and SSN with the P number determine hours. So you can separate them. But the concept of the first normal form, the first one, no multi-value. The second one, no nest attribute. The nest, you have to separate them. Okay. What else? The concept of first normal form, we have to check composite attribute, multi-value attribute, nest relations. You have to, if you found one of them, you just separate them to the new relation. Okay. This is the first normal form. After the relations satisfy the first normal form, then we check the higher level. So we're going to see the second normal form. In second normal form, use concept of functional dependency and primary key. Now you know primary key, right? Primary key. Before primary key, we call candidate key. Because before candidate key, it should be a key. Before key, it must be super key. Okay. You have to understand all of the concept of them. Okay. And now, primary key. Okay. In primary key, maybe the set of attributes. Inside of the primary key, we call prim attribute. Now, prim attribute. An attribute is a member of the primary key K. So the concept we need is full functional dependency. Full functional dependency. Y determine Z, where no removal. Where removal of any attribute from Y means functional dependency does not hold anymore. So Y is the smallest set of the key. Okay. For example, SSN and P number together determine hours is full functional dependency since neither SSN determine hours nor P number determines our whole. You cannot separate them to determine hours. If you can separate them, just only which one can determine the hours is not called full functional dependencies. If both of them are become the primary key of the table. And this one also, SSN and P number determine ename. If SSN and P number together is defined as the primary key of the table, but in this relation we know that just SSN is enough to determine ename. So this one we call partial dependency, not full functional dependency. So if we have this kind of relation, this relation or this table not satisfy the second normal form. Here relation schemas is second normal form if every non-prim attribute A in R is fully functional dependent on the primary key. Non-prim attributes are the set of attributes not a member of the primary key. They must fully functional dependent on the set of the primary key. R can be decomposed into second normal form relation via process of second normalization or second normalization. Okay, just separate the function. For example, here, example. Now we have the M project, right? The M project. Okay. Primary key now is SSN and P number. Both of them together is a primary key of the M project relation. Inside the set we call prim attribute, and the outside of the set of attribute here to here we call non-prim attribute. Okay. After that, the concept of second normal form is fully functional dependency to all members of the primary key. So here the second one, this functional dependency, ename determined by SSN only, right? As you can see, this arrow, just only SSN is enough to determine ename. So ename is just partial dependent to the primary key. This one not satisfy the second normal form. So we have to separate this functional dependency to be the new relation here. SSN and ename. We separate to a new relation. And also the other one here, project name and project location depends on determined by the P number only, right? As shown in the functional dependency number 3. So this one not satisfy the second normal form, so we separate into the new table here. P number, P name, and P location. This one is a key, and the non-prime attribute depends on the whole key, just only one attribute. That's fine. So this one already passed second normal form. Okay. How about EP2? This one, this relation. Okay. Non-prime attribute depends on the whole key. Okay, just one attribute. So this one is so passed the second normal form. And the EP1, we have 2 attributes as the key, and ours here depends on the whole key, both of them. So this one also satisfy the second normal form. Second normal form, we check just how many members in the attributes, and the non-prime have to depends on all member. So if we check here, just this one, second one and the third one not satisfy the second normal form. Okay. Now, the first normal form, we know that we cannot use the composite nest attribute or multi-value. And second normal form, if the attribute depends on the key, the attributes have to depend on the whole key, not a part of them. And next, third, not yet. Okay, normalizing into second normal form and third normal form, but the third normal form still not talking about it yet. Wow, we have lots. Okay, let's see. Normalization into second normal form and third. Okay, lots relation with the functional dependency 1, 2, 4 functional dependency. Okay, we check that now we have a key. Which one? Property ID is a key. Why it is a key? As we can see that from the functional dependency number 1, property ID can determine the remaining attribute, all of them. If you just look at the functional dependency like the first one, if one of the attributes can determine the remaining attributes, so that attribute can be the key. And also the second the second functional dependency, country name and lot number, both of them together can be a key also, because both of them can determine the remaining information, remaining attribute. So this one can be also the key, but we not select it as a key, so we call it just candidate key. If we select the property ID as the primary key, country name and lot number become secondary key. Okay, let's see what should we do for the second normal form. Let's back to check the second normal form. Fully functional dependencies. Attribute member primary key. Okay, just primary key. If we talk about primary key, that's fine. B, decomposing into second normal form relation loss 1 and loss 2. What it is? So in this concept, they are also concerned about the candidate key, because the tax rate here is partial dependence on the set of attributes of the candidate key. So we check that this one is not satisfied, the second normal form. So we separate this one to the new relation. So B already satisfy second normal form. Now, if we look at these two examples, we can say that when you check the partial dependence, it's not only on the primary key, but also for the candidate key. If we have partial dependence on the candidate key, we have to separate them into the new relation also. After that, the loss 1 and loss 2 already satisfy the second normal form. The keyword of second normal form is here, partial dependency. Partial dependency. Or you can remember full functional dependency, that's fine. And next, third normal form. About the third normal form, the definition is transitive functional dependencies. Okay. If we have functional dependency X determines Z, that can be derived from two functional dependency X determine Y and Y determine Z. Here we call transitive functional dependency. For example, SSN determine department manager SSN. This one is transitive functional dependency because SSN can determine the department number, and department number determine the manager SSN, right? So we call that, when we know the employee, we know the manager of the department that the employee belongs to. we know this relation is the transitive functional dependency. And also SSN and ename, what is that? This one is direct, right? It's not transitive. Since there's no set of attribute X where SSN determine X and X determine ename. And this just only direct from SSN to ename, not transitive. So if we found the transitive dependency in the relation, we have to separate them into the small one. Okay, a relation schema R is the third normal form if it is in second normal form. But it is become second normal form if the relation is the first normal form before. So we have to check for the lower normal form before the higher. So we can make sure that if it's second normal form, this of course first normal form already. Okay, and no non-prime attribute. Prime attribute. Okay, A in R is transitively dependent on the primary key. R can be decomposed into third normal form relations via process of third normal form normalization. Okay. In X determine Y and Y determine Z. With X is a primary key. Okay, now X is a primary key. We consider this problem only if Y not a candidate key. Okay, when Y is candidate key, there is no problem with the transitive dependency. Okay. This is not that if Y not primary key, but Y is a candidate key. For example, student ID determine SSN, and SSN determines student name. We not count it as the problem, okay? And we don't have to separate SSN and student ID to be the other tables. Here is consider SSN and employee number. Okay, employee number is also candidate key. SSN is primary key. So actually, we can say that SSN determine employee and employee determine salary. But in this case, we don't separate the tables because employee number is candidate key. Back here. Now what should we do? Okay, B. In this relation we have employee department, right? And D number determine D name and D manager SSN, but D number here is not a primary key. But this one is determiner. So we will have SSN determine the number, and then the number determine the name. So in this relation, it's become transitive functional dependency. Actually, it's very easy to check because you just check on the SSN. It's a primary key, right? If the arrow start from the other place, not primary key, this one we call transitive. So we have to separate this kind of the functional dependency to the new relations. But don't forget that when you separate the table using the number become the primary key here, you have to remain the foreign key in the original table. Okay, you need this one to remain the relation. Don't delete it. If you delete the number from the original one, you cannot join it back together. Okay. Every year we have students who delete the number from the original one when you decompose it. Don't forget it still remain it because it should be the foreign key to join with the other table. Okay. Don't delete it, the number. Okay. To check the transitive again, what should we do? We just focus on the primary key. Okay, the primary key is here. And if you have the other set of the arrow, start from the other attributes, not primary key, it becomes transitive. That's all. So, here, this is the primary key. So, this one is no problem. This one is no problem. Functional dependency 2 and 3 is no problem because they start from candidate key. But for this one, the fourth functional dependency, the arrow now start from candidate key or primary key. So this one is a transitive. Transitive dependency is transitive. So this one, FD4, is transitive. So if you found the transitive, you have to separate them. Now, B, the second normal form. Okay. Here still remain, right? You separate into the new one. So, C, already third normal form. Yep. D, just show lots only is just first normal form, and when you separate to lot 1 and lot 2, it becomes second normal form. And when you separate the lot 1 into lot 1a and lot 1b, it's become third normal form. So now we can summarize. Very simple. First normal form, all attributes depends on the key. No multi-value, no nest, okay, no composite attribute. Just atomic, just one value in one row. Second normal form, all attributes depends on the whole key. Cannot depends on the part of the key, just the whole key only. And about the third normal form, attributes depends on nothing but the key. Depends on only the key. Okay. If some of prime attribute depends on the other prime attribute is become transitive, not the key. So we have to separate them to the other relations. Now, we're already talking about the first normal form, second normal form, and third normal form. But before you can do that, you have to understand about the functional dependencies. And you have to understand the concept of the key, right? Key, super key, candidate key, primary key, secondary key, prime attribute, non-prime attribute. What else? General form, general normal form definition for multiple keys. Okay. The above definitions consider the primary key only. The following more general definition take into account relations with multiple candidate keys. Any attribute involved in candidate key is a prime attribute. That's why here the FD3 depends on just part of the candidate key, right? And the part of the candidate key we call the prime attribute depends on part of the candidate key. So this one is violate the second normal form. Okay, so it's writing here. Any attribute involved in a candidate key is a prime attribute. All other attributes called non-prime attributes. Okay. So the prime attribute not only belong to the primary key, but also the candidate key we call prime attribute. And general definition of second normal form for multiple candidate keys. Okay, a relation schema R is in second normal form if every non-prime attribute A in R is fully functional dependent on every key of R. Okay. So in the previous figure, country name determine tax rate, violate second normal form. Okay, let's back to here. This one. So, this is a key, and we call this is prime attribute. And also in candidate key, we have two of attributes also called prime attributes. And country names determine tax rate is just partial because the candidate key here include two attributes, but just one of them determine tax rate. So this one is violate second normal form. So that's why we have to separate them into the new relation. This is details of second normal form with multi-candidate key. What else? So the multiple candidate key. Okay. So second normalization convert to two tables, and we separate the partial relation into the new relation. That's all. And general definition of third normal form. Okay, so we're talking about the super key of relation schema R, a set of attributes S of R that contains a key of R. Wow. A relation schema R is in third normal form whenever functional dependency X determine A holds in R, then either X is a super key of R or A is a prime attribute of R. Lots 1 relation violate third normal form because area determine price, and area is not a super key in lots 1. Okay, just back to check 14.1.2 area lots. This one area price. This relation area and price violate third normal form here in the fourth relational dependency. This one violate the third normal form. Anyway, this is a concept and definition, so you just remember the transitive, separate the transitive to the new one. Just enough. There are two a lot of details. What else? Interpreting the general definition of third normal form. Consider two conditions. Two conditions in definition of third normal form. A relation schema R in a third normal form if whenever, this one is already talked about that already. Okay. X is a prime attribute of R. A is a prime attribute of R, and X is super key of R. Boom. Condition A catch two types of violation. The first one, where a prime attribute functionally determines a non-prime attribute. This has second normal form violations due to non-full functional dependencies. Okay. And second, where a non-prime attribute functionally determines a non-prime attribute. This has third normal form violation due to transitive dependency. Yes, non-prime determine non-prime, so we call that transitive, right? Okay, this is two violations. The first one is for second normal form, and the second one is for the third normal form. What else? Alternative definition of we can restate the definition as relation schema R is in third normal form if every non-prime attribute in R meets both of these conditions. The first one is fully functional dependence on every key of R. Okay, is the third normal form, and it is non-transitively dependent on every key of R. Same story but different explanation. Okay. The condition B from last slide take care of the dependency that slip through third normal form but are caught by boycott, which discuss next. Okay. So the last one, we talking about the boycott normal form. Relation schema R is in boycott normal form if functional dependency X determine A holds in R, then X is a superkey of R. X is a superkey. X is superkey. A superkey determine A. Okay. Each normal form is strictly stronger than the previous one. Every second normal form relation is in first normal form. Third relation is in second. Every boycott relation is in third normal form. Okay. So the X is relation that are third normal form but not boycott normal form. Boycott is quite more strict than the third normal form. So here, boycott consider a stronger form of third normal form. Okay, the goal is to have each relation in boycott normal form. Let's try to do that. Here is quite complicated one. So A is the last one A already satisfy the third normal form, but now we have functional dependency 1 from the primary key and the second one from the candidate key, and we also have this one, the fifth one. Area can determine the candidate the country name. The boycott normalization of loss A with the functional dependency FD2 being lost in the decomposition. Actually, boycott also concerned about the transitive. As you can see here, the transitive is from area can determine the country name because area is not a part of the primary key. It is also not a part of the candidate key also, right? It's just a non-prime attribute. But the area can determine the other attribute. So this one we can also call the transitive attribute. If we have the transitive like this, we have to separate them into the new one. So we separate them into the new area, determine country name, but what is happening? So the first functional dependency still remain here, area. And area is foreign key, right? Foreign key. So we can get the country name. We can still get the country name from both relations. But for the second functional dependency, this one lost after we decompose to the boycott normal form. Yes, it will become like this one. Okay, and B is very difficult one. B is schematic relation of functional dependency. It is in third normal form, but not boycott due to the functional dependency. C determine B is still remain. This one is quite difficult. We have to separate. Actually, we have to separate it if we want to be certify the boycott into the table, small table. The table will change to A and C determine B. But don't worry, it's just example. It's very complicated one. Not going to be one of the questions in final examination. It's too complicated. Just give you the example how boycott work in the example. Okay. So this one is relation teach, that is in third normal form but not boycott normal form. But how to check it? So they said that in this example, student and course determine instructor and instructor determine course. Student and course determine instructor and instructor determine course. Wow. If we found this kind of the relation, this one is already third normal form, but not boycott normal form. Okay. So student and course is candidate key for the relation, and that dependency should show in pattern in figure 13b. Here, it is similar to this schema. And so the relation is in third normal form but not boycott normal form. A relation not in boycott should be decomposed. So as to meet this property, while possibly forgetting the preservation of all functional dependency, because some of functional dependency will lost after you decompose, but this problem can relax in the boycott normal form. So we can decompose it like student instructor and student course determine instructor determine course, and course student here both of them as the primary key, and instructor determine course and instructor and student together. So we can separate several ways. All three decompose will lose functional dependency number one. Yes, but we have to settle for sacrificing the functional dependency preservation, but we cannot sacrifice the non-additively property after decomposition. Out of the above three, only the third decomposition will not guarantee spurious tuples after join. Actually, sometimes when you lost some functional dependencies and then you join it back together to one table, sometimes we will have problem about the lossless join. So, I never do that. I just leave it leave it there and use it as it, not separate into too small. If you separate into very small one, sometimes you lose the functional dependency, and when you join it back, we will have problem about the lossless join. Okay. This is the concept of boycott normal form. And test of checking non-additive of binary relational decomposition. Okay. So actually you have to test it after you decompose. Testing binary decomposition for lossless join or non-additive join property. Binary decomposition, okay, decomposition of a relation R into relation from one relation separate into two. Property NJB, non-additive join test for binary decomposition. Oh, it's really long. A decomposition D becomes R1 and R2 of R has lossless join property with respect to a set of functional dependency F on R, and if and only if either the functional dependency R1 intersect R2 determine R1 minus R2 is still in the set of functional dependency. F plus is the set of functional dependency of all of them. Or R1 intersect R2 determine the R1 minus R2 is in the set of the all functional dependency. Okay, anyway, it's quite difficult for the concept of the abstraction. Actually, you have to try to join it back together and count the row of the information. That's all. It's very simple one. If you apply NJB test to 3D decomposition of teach relation, D1 gives student determine instructor or student determine course, none of which is true. And D2 give course determine instructor or course determine student. This also none of which is true. However, the last one, D1, we get instructor determine course or course determine student. Since instructor determine course is indeed true, the NJB property is satisfied and D3 is determined as non-additive, on meaning is good decomposition. So you have to calculate the set of the relation using this concept, the first one and the second one. Okay, I would like to skip this one because we never talk about the algorithm in 15. And just the concept of the fourth normal form. This one we're talking about the multi-value. And we try to separate them, but it's not easy to understand because it's really complicated. Fourth and fifth normal form. Okay, this is an example here. A is the employee, right? Employee, E name, P name, project name, and D name. Actually, Smith, as you can see, Smith worked in several departments. Oh, D name is what? Smith and D name is employee with multi-value, E name multi-determined P name, and E name multi-determined D name. Smith pair to several values of the P name, and Smith also pair to the several of the D name. Is multi-value determination. As you can see, we have to use 3 of them together as the primary key. as primary key in this relation. When you separate it, actually we have to understand the relation at first, but you cannot use this kind of information only. You have to ask for the requirement to understand the relation of them. After that, from this information, they suggest to decompose M relation into two. In B, become the M project. Smith work in X, project X and project Y. Okay, we can check from this one. And we use both of them as the primary key. And here is M and dependent. We can see Smith work for John and Anna only, right? The problem is when you join back, right? It's become something so risky, because here you join with the ename and ename, right? When you join using ename and ename, what does happen? It's become Cartesian production, because this one is not unique. This one also is not unique. Okay, you can separate if you sure about the concept, but I not suggest that. So this is just the concept how it works with multi-value. Okay, and I would like to skip the fifth one. It's very difficult to explain. Anyway, now that's all for this chapter. So the first one, normalization concept. Why we have to do normalization? To reduce duplication, to reduce the what else? Now value, and we use normal form to check the concept of the good schema. And we have the first normal form, second normal form, third normal form, and boycott. Before we normalize it, we have to understand the concept about the key. The first one is a super key. After that, the smallest set of super key is become a key and become a candidate key. And from candidate key, you select it as a primary key, and the remaining candidate keys become secondary key. The attribute inside the primary key and candidate key we call prim attribute, and the others we call non-prim attributes. And we use this concept to check first normal form. Okay, about the first normal form, the concept is one word: atomic. So if the data is become atomic, it's not the composite attribute, it's not the next attribute, it's not the multi-value attributes. So become atomic. And next, after you certify the first normal form, we can check the second normal form. The second normal form we check just only if the prime attribute depends on non-prime attributes have to depend on the whole key, not a partial of them. And then we check the third normal form. Third normal form, the concept is just transitive attribute. If we found the transitive attribute, transitive functional dependency, we just separate the transitive functional dependency to be the new one, but don't forget to remain the foreign key in the original table. And the boycott also check the functional dependency like transitive, but the more strict one. After you separate the table, of course you will reduce the number of the redundant data. For example, here, as we can see that the D number in the table here is redundant, a lot of them, right? If you separate them, it's become just unique, because D number, D name, and manager separate to the new table, and the number will become the primary key and become a unique value. So the new table, like for the department number 5, will show just only one tuple, right? So you can reduce a lot of duplication in the new table. But when you separate them and you want to retrieve the name of the department, so you have to join them back to the table and show them in the result. So when you join, you will have job to calculate when you join, right? Can you remember the join? Okay, when you join, you have to do what? Cartesian product. After that, you filter it, right? So it's a lot of work. If you have a million of the rows, so please do not join them. Use this kind of the table that more faster to search for the information. This is trade-off problem when you separate, decompose the table into a small one. So this is trade-off. You have to calculate and try to design the performance, improve the performance of your database system after you launch it. You understand when you have a lot of data. Yes. Okay, now that's all for the concept of the normalization today. Very simple, but I think you need some examination for practice. Maybe a little bit, maybe good for you. And this one, let's try to practice to find the functional dependency from the data so you can understand. Can you find it? Can you? How many? Oh, how many is too difficult. What kind of the functional dependency may exist in this table? How to find it? How to find it? Okay, again, one, just one. Okay, C2B, you want to go home, right? C2B is very fast. Because if we check, okay, C2 and C2, the same determiner, we need the same value. This one may exit in this relation. Okay, thank you so much today. See you next week. Bye bye. I will give you homework later. Okay, just 1 or 2 questions.